This question comes from Traves, who asks, if all the lightning that occurs worldwide in a single day struck the same place at once, what would happen? They say lightning never strikes the same place twice. They are wrong. It's surprising this saying has survived so long. You'd think people who believed it would have been naturally filtered out by now. People often wonder if we could harness electricity from lightning. On the surface, it seems reasonable. Lightning is electricity, and lightning strikes look powerful. But a lightning bolt is over so fast that the total energy delivered isn't as extreme as you might think. Plus, trying to get lightning to strike where you want it is nearly impossible. A typical lightning bolt carries enough energy to power a residential house for about 2 days. Even a building like the Empire State Building, which gets struck around 100 times a year, couldn't keep a house running solely on lightning power. Even in high lightning areas like Florida and the eastern Congo rainforest, the power delivered to the ground by sunlight outweighs that of lightning by a factor of 1,000,000. This makes sense, considering lightning itself is ultimately powered by sunlight. Trying to generate electricity from lightning would be like building a wind turbine powered by tornadoes. Impractical, though admittedly, very cool. Now, in Trevor's scenario, all the world's lightning bolts strike a single spot at the same time. Suddenly, energy collection becomes a much more appealing idea. Let's assume all the bolts land in parallel, tightly packed against each other. A single lightning channel, the part carrying current, is about 1 centimeter or 2 wide. With around 1,000,000 bolts, our super bolt would form a column about 6 meters in diameter, hitting an area roughly the size of a basketball court center circle. Since science writers love atomic bomb comparisons, let's get that out of the way. This mega lightning strike would release about twice the energy of the Hiroshima bomb. In practical terms, it could power a game console and TV for several million years. Or, we're thinking bigger, could sustain the entire United States electricity consumption for 5 minutes. While the bolt itself would be confined to the size of a basketball court center circle, the resulting explosion would carve out a crater as big as the entire court. Inside the strike zone, the air would turn into high-energy plasma. The blinding light and intense heat would instantly ignite everything for miles. The shockwave would flatten trees and demolish buildings. All in all, the Hiroshima comparison isn't too far off. Could a lightning rod absorb this energy? Well, lightning rod's functionality is still debated. Traditionally, they are thought to provide a safe channel for lightning to reach the ground, though some argue they actually prevent strikes by steadily equalizing charge between the ground and sky, reducing the risk of a bolt forming. Either way, a lightning rod wouldn't save you from Trevor's lightning. A meter-wide copper cable might, in theory, withstand the current surge without melting, but whatever is on the other end would likely be obliterated in an explosion anyway. Collecting all the world's lightning into one place is clearly unrealistic. But what about gathering all the lightning from a single region? No place on Earth experiences constant lightning, but one location in Venezuela comes close. Near the southwestern shore of Lake Maracaibo, a bizarre phenomenon occurs. Near perpetual nighttime thunderstorms, 2 hotspots, one over the lake, one over nearby land, generate lightning flashes as often as every 2 seconds, making Lake Maracaibo the lightning capital of the world. If you could somehow channel every bolt from a single night of Catatumbo thunderstorms into a massive capacitor, you'd store enough power to run a game console and TV for a century. If this happened, we might need to update the old saying, lightning always strikes the same place. That place is in Venezuela. You shouldn't stand there. If you enjoyed this story, make sure to like this video, it really helps us out. Share it with friends who'd love to learn something new, and subscribe to the channel for more fascinating content like this. Don't forget to turn on notifications so you never miss an update. Thanks for watching, and I'll see you in the next one.